Hope you had a good Thanksgiving and Merry Christmas. And the reason for this video is, to some folks this is going to seem quite elementary, okay? I like to deliver my videos and deliver things to folks in the simplest, most broken down form I can possibly do so that folks get it. Let me set up the situation. This was about 2 weeks ago. We had two crews out with the perma-green spreading out granular fertilizer, what we call our round 6, on yards. And the day was, I wouldn't call it rain. What I would call it would be a heavy mist, maybe a light drizzle. Just enough to where we had to put the actual hopper cover over the hopper of the perma-green, because there's just enough water falling from the sky to actually start to melt the fertilizer we were putting out. So obviously you want to keep that dry so that the fertilizer doesn't clog up and mess up your application, your rate, your pattern, all that blah blah. So I pulled up to this house. The gentleman was pulling out, the homeowner, and said, "Hey, it's raining." And of course, my definition of raining was a little different than his definition, because it wasn't actually raining. Raining is when it's coming out of the sky so much to where your clothes get wet and you're miserable working in it. That's what I call raining. This was a heavy mist, so obviously we're in production, so we have to keep going on days when it's a heavy mist or a light drizzle. We don't slow down, we just work right through it and deal with it. So this guy rolled up and said, "Hey, it's raining. How's that going to affect the fertilizer?" And so I've answered that question 10 million times to customers. So immediately, without hesitation, I said, "Well, it's going to be great for it. It's going to work it right in the ground and we're good to go." So that was the quick answer. So now I'm going to give a little more detailed answer to how does rain affect fertilizer? How does water affect fertilizer? We're talking specifically about a granular fertilizer that you put in a spreader and spread out, not a liquid. They work in two different ways. We'll do one about liquid later. This is specifically for granular. Let's dig in. You can see I went and collected a couple of samples from the shop. This is our 27010 that we put down for round 6, and this is our 1820-2 that we put down for round 5 in conjunction with aeration and seeding. So you can see this noticeable difference in color. Well, that's because there's different things, different nutrient quantities in each bag or that are specific for whatever time of the year you're working in. So now you're going to hear me talk about prill several times in this video, and just to clear the air so you'll know what prill means, is they label it as SGN, which is size guide number, meaning the size of the prill, meaning how big around it is or how small it is, the diameter of it. And for typical professional use fertilizers, they're typically going to be 220, a 220 SGN. When we custom order or custom blend our fertilizers, I specifically say I want a 220 SGN, and which actually I don't even have to tell the guy that. He already knows that because he knows what I'm using it for. And I like that particular size because it flows out of the spreader well. It's easy to calibrate, all that kind of thing. So without getting into serious detail on what all these letters mean, that's not the gist of this video. I'm not trying to get into debates on what all the different nutrients do for turf. We want to see how it reacts with water. Now, of course, I can't go outside and snap my fingers and make it rain. So the next best thing is we're going to use regular old tap water and get a good idea of how water affects fertilizer. So on most bags of fertilizer, you will see N, P, and K. All right, N, P, and K: nitrogen, phosphorus, potassium. These are your what are going to be called your main nutrients, or you know, the nutrients that are most needed by plants. Nitrogen being the big dog. You can see here the nitrogen. There's two different colors. One is white, and let's get something here to point to. One is white. This is urea nitrogen. This is what we would call a quick release nitrogen. It's just straight out of the ground urea. Then the green is going to be XCU. That's basically a coating that they put on the nitrogen to make it release slower. This looks black in the video. I'm sitting there looking at it, and it looks black to me, but it's actually a brown color. This is your phosphorus. This is going to be for your root development. That's why you see the middle number, phosphorus, is the highest. We put this down with seed because the grass seed just germinated. It needs that phosphorus in the ground so that root system can get going. Potassium, there's a couple of forms of potassium that are available: muriate of potash and sulfate of potash. Both of these are sulfate of potash, SOP. It's basically a higher quality form of potassium. These just come from two different sources, so we're going to use them both and see what's up. Potassium is great for stress. It helps the ground hold moisture, helps hold moisture in the plant, that kind of thing. The H is for humate. You're wondering what humate is. Well, humate, when you take this and melt it down in water, when you liquefy this, it becomes humic acid. Humic acid or humates are not fertilizers. They're basically a complement to the fertilizers that you're putting out. Basically, in a nutshell, I'm not going to get into a big discussion about humic acid. There's tons of videos all over the place about humic acid. There's tons of info on it with Google or whatever. But it basically, in a nutshell, it's a great soil conditioner. It helps the plant use these other things that you're putting in the ground, basically. Can you get humates or humic acids mixed in your fertilizer when you go to Lowe's and buy it, or when you go to Site One or John Deere? Typically not. Typically they don't add that. This is why we call this a custom blend, is because this is extra that we source this out from a place in Florida, and they ship us 2,000 and 4,000 pounds at a time, and then we take it and deliver it to the fertilizer company, and they mix it in with the other nutrients. Micronutrients. Now you see I changed that. I got in a hurry and wrote macro. These are going to be your macros over here, your main, and then your micros are things along the lines of sulfur and boron, iron, magnesium, zinc, all those things. It was very difficult to get this out because the percentage of micronutrients in a bag of fertilizer is very, very small. There's not a lot in there because, and it kind of relates to what they're called, a micronutrient, meaning they need micro doses of it. It doesn't take a lot of micronutrients. It doesn't take a lot of iron. It doesn't take a lot of sulfur, a lot of zinc, or whatever. So that's why the doses are in such small quantities. And when you're talking about a bag of fertilizer with all these prills, it took me forever to source those out. Our filler. What do I mean by filler? Filler is when, if you went and bought a bag of fertilizer, and let's say it's a 10-10-10, 10% nitrogen, 10% phosphorus, 10% potassium. Well, 30% of a 50-pound bag is this. Well, that means the rest of it has to be something to make up 100% of the matter in it, or the size of it, if you're following me on that. So most of the time, that's sand, rock, little pebbles. Some companies will put lime in there as filler. Well, we choose to use biosolids. And biosolids is basically Milorganite. It's pretty much the exact same thing. And that way, it costs us a little bit more to add those as opposed to the filler. But at the end of the day, you're getting a better bang for your buck. You'll find out with me, I am all about value. I do not mind spending the extra $1 per bag if it creates value in my yard or in my application or in our service as a whole. So we use the biosolids for that, and the filler. And I was just super duper curious. I had a little Milo left over from my experiment the other day, and I wanted to see how it reacts with water. So you can see it's a noticeable difference in the prill size. Let's get one over here. So you actually, now whether or not my biosolids that we use are as good or better than Milo, I do not know. I have no clue how to gauge that. But I do know, look at the size of it. So it is bigger in size, the SGN. So let's see how this works. Let's put them in some water and see what happens. All right, so here's your nitrogen, both the urea along with the XCU coated. Let's pour that down in there. All right, here's your phosphorus. And again, this was a brown in color. You will also find that some phosphoruses will be a reddish color, maybe even pink. Here's the phosphorus going in. Here is the SOP, or sulfate of potash. And remember, you know, fertilizer manufacturers, or the companies that actually get the stuff in on rail cars and bring it back and blend it in bags and then sell it, you know, they use different places to get different things. So that's why that sulfate looks a little different, is because they got it from a different source. It just come out of a different part of the country or a different mine or something along those lines. All right, here are your micronutrients, your iron, zinc, those kind of things. These are the biosolids that came from our blending or our fertilizer. Yeah, this is not the Milo, this is just the biosolids. Let's see what that does. And then let's go ahead and put in, I'm not even gonna try to do that. Watch back, watch out, bud. Let's go ahead and put in some of the Milo here. See what happens there. And I saved the humate for last because it is, out of all of these, it is going to be the most water soluble in here. It's going to be pretty much instant when it goes in. Let me get all this up here.
That is a lot of mayo there.
Mm-hmm. Let me bring you down close to the humate, because watch this.
Ow.
See how quickly it starts to dissolve? The potassium is starting to break up pretty instantly. Oh, this is interesting. Look down in here, no white urea. So the quick release urea has already melted in and has already started working its way into the soil, where the XCU is still kind of hanging around a little bit. And you can see some of the coating here trying to start to break off or break down. The phosphorus, the color is changing of the water, so it's starting to break down. The humate is almost completely melted. The micronutrients, you can see the sludge on the inside of the container, they're starting to break down. The biosolids, you can see down in the bottom down there, the little bit of color, it's starting to break down.
A lot of Milo.
Not seeing anything on the Milo yet. So let's get something to stir these up a little bit and see if we can't agitate it, see what happens. All right, let's take something and agitate this a little bit. And again, it was just a matter of seconds when the plain urea with no coating on it was gone. It was just a matter of 10 or 15 seconds. You can see here the XCU is still kind of hanging on a little bit. You see that discoloration in the water. I'm hoping the video picks it up good. You can see the discoloration, how this is still clear. And this is the phosphorus is starting to break down. And here's your potassium, potash. Let's go down here and do the micros first. There is discoloration in that water as well. Let's go to the biosolids. And let's go to the Milo. And go back to the humate. Remember, I didn't want the screwdriver to get dipped in here and then transfer it over to here, so it didn't look right. Look at this. There is your humic acid. That's where humic acid comes from. It's from the actual humate source. And you can see it's highly water soluble, extremely. So a little overhead view, you can see the nitrogen's still a little clear. It's got a little haze to it, but that's because it's got the urea is melted down in here. The phosphorus has started to break down already. The K has broken down already, or starting to. The humate is completely solubilized. The micros are starting. The biosolids, you can see them starting to break up down in there. They're starting to break down. And the Milo, it's still in the granular form. Not trying to take anything away from Milo, good stuff. I was just curious to throw that in there to see what happened. So I'm gonna give this, it is 1 o'clock. And I'm going to give this about 2 hours. So around 3 o'clock, I'm going to come back, re-agitate this stuff, and kind of see where we're at then. I'm curious to know if it's going to take a little more water. I kind of had a good idea this was what was going to happen, because typically it takes a couple, even 3 good irrigation cycles, good waterfalls, to actually get the P and the K and the biosolids to actually get broken down and start working its way in the ground. The phosphorus is going to take even longer than that, just because it moves slowly through the ground. So I'll be back in a couple of hours and we'll see what's up.
Look at the H.
What?
Look at the H.
The
already.
H done really good, didn't it? Look at
Yeah,
that.
it was focused.
Yeah, I know. Yeah, the H is focused. Yes, it melted down quite quick, didn't it?
Yeah.
Yeah, man.
But the other ones were not.
No.
Not all of them. All of them were not focused except for the H.
That's right, the H. You got it. Well, you heard it right there from Jax. It's all about the H. So here we are back 7 hours after each nutrient was put into its respectful beaker. And you know, I was going to check it after 2 hours, which I did, and there wasn't much activity going on, which I kind of expected that. So I waited 7 hours, and here we are. The nitrogen, the XCU, is still slow to break down. You can see the phosphorus has quite a bit of it is dissolved. It's going to be probably the most slowest out of all of these. Now here's one of the differences in a SOP and an MOP. The sulfate of potash is far more water soluble. Is my understanding of it. And look at that, it's completely gone, turned into basically a liquid potash now. Of course, your humic acid now has been dissolved. The micronutrients gone, except for those 4 little pebbles. I think that is the iron in there. I believe it's what is left over. And then here's the biosolids we use, which have broken down considerably. And then the malorganite is still kind of hanging on. It's still got its own, it's still holding its shape, but you can see the colors of the water. It's starting to break down. This is a little darker than this. This broke down kind of clear. You can see the difference in the color here. So I'm going to check it tomorrow at 1 o'clock. That will give us 24 hours of being completely submerged in water, and that'll give us a little better idea of how long it takes for these things to break down. Okay, so here we are 24 hours later from the time that we put each of the nutrients into their own container here. And again, the point of the video is to simply make a point. Your granular fertilizer needs to be watered in, whether it be from rain, irrigation, manually watering it, whatever. It simply needs to be watered in to be activated. You can see this fertilizer is still intact. It's still dry because it hadn't had any water, so it hadn't melted down. And again, not trying to be sarcastic, I'm simply trying to make a point that water is crucial to not only fertilizer applications, but crucial throughout the entire year to maintain a healthy yard. So let's check them out again. 24 hours later. Here's your urea, and of course the quick release is gone. And you can see a lot of these pebbles are starting to float now. They're getting lighter because the water is kind of eating away at the coating, that slow release coating. Here's your phosphorus. There's actually less pebbles in here now, so that's melting down. You can see the difference in the color. And of course the potash, it was gone maybe an hour after. And the humic acid that's humic acid. And here's your micronutrient package. The little iron pebbles are still, I don't know if you can tell, but I can almost say that they're getting a little smaller. Here's our bio-solid, which we get blended in instead of filler. And you can see it's broken down quite a bit. And then here's Mr. Milorganite, which still, I mean, it's getting there, slowly but surely. But they market that as a super duper slow release type of food for the yard. So that's my common sense guess as to why that's like that. So what happens if you make a fertilizer application and you don't have irrigation, or you're not going to water, or it doesn't rain for a week or 2 weeks or whatever? Well, I don't really know how humidity and moisture in the air and maybe moisture in the ground will affect this. I'm sure it does affect it in some way, because you see how water soluble some of the products are. So any type of moisture present is going to start the activation. But for the most part, it'll sit there and wait on the rain to come. How can I compare this to the amount of rainfall? Like would this represent 2 weeks of straight rain, or would it represent a day of straight rain? I don't know. I don't have any clue. It's just, the point is, water needs to be present after you make a fertilizer application. That's just the bare bones about it. So I hope this helped. I was kind of curious to see for myself, to be honest with you. So hope you learned something. I know I did. Check you later.